All right. What now? So before we do this, I want to just point out that you can just verify this. If I didn't say using the trigonometric sum and different formulas, there'd be a much easier way to do this. And I'm just going to show you visually what you're looking at. So cosine looks like this, right? And minus sine, instead of going up from the origin, it's going to go down. And so what this picture means, what does this shift mean? It means cosine of pi, here's pi, minus theta means you start there but you move backwards. So you're starting at -1 and then you're moving towards 1. And that's how you're going around the sine and cosine curve. What about this second one over here? Theta plus pi over 2, where's pi over 2? There's pi over 2. But you're moving in a positive direction, so you're doing this kind of thing. Oh well, you're starting at -1 and you're moving up towards 1. That's exactly what you're doing in the cosine situation. You're starting at -1 and you're moving up towards 1. Since they're both doing the same thing, and the speeds are the same, right? Because minus theta or theta doesn't matter, just direction changes, but it's the same speed. So these guys are, that's correct. I'm happy. I'm sure these are correct. I don't need any further proof. But it says using those formulas. So let's go ahead and use those formulas. So let's try cosine of pi minus theta. And so the cosine formula, cosine a plus b, cosine a, cosine b, minus sine a, sine b. And maybe you're saying, oh, just go ahead and use the difference formula, please. Okay, fine. Instead of cosine b, it's going to be cosine of negative b. Cosine of b and cosine of negative b are the same. Sine of b and sine of negative b, well, there's a negative sign. So that's all that's going to change. Okay? And so I can go ahead and use the difference formula if I prefer. Here we go. Cosine of pi, cosine of theta plus sine of pi, sine of theta. Well, what's cosine of pi? I don't know. Well, it's too little. Cosine of pi. Cosine looks like that. Here's pi. Ah, that's a -1. Well, what does sine of pi look like? I don't know. What does sine look like? Sine does this kind of thing. Here's 2 pi. Here's pi. That's 0. This thing goes away. Oh, great. So the left-hand side boils down to minus cosine of theta. How wonderful. That the right-hand side is still a mess. So let's see if there's anything we can do about that. Well, yeah, I guess we need the other formula. We need sine of a plus b, sine of a, cosine of b, plus sine of b, cosine of a. There we go. So let's go ahead and plug everything in, except that there's a minus outside of the whole mess. Great. Sine of pi over 2, cosine of theta, plus sine of theta, cosine of pi over 2. Oh, good. Now you're going to tell me I need to know the sine of pi over 2. Sure. Here's 2 pi, here's pi over 2, that's 1. So this equals 1. And what about cosine? I got to know the cosine of pi over 2? Yeah, sure, that's not a problem. You just draw yourself a cosine curve and say, okay, that was a little too messy. Little cosine curve there. And here's cosine of pi over 2. Oh, great, this one is 0. So this whole thing is gone. And so what we end up with is minus cosine of theta, which conveniently enough is what we got on the other side. So this is the left-hand side, right-hand side, and they're equal. So we are happy.